Hello again, everyone. Mr. Cruze here with another Algebra 2 review for you. This time, the final exam review, part 5. Alright? We're going to do as many problems as we can in this video. Again, you can always tweet me, email me, post a comment on this video at any time. If you have any questions, you can always come in and see me in the morning or after school. I will be glad to help you out. I want you to see how well you can do on this final. Alright? Push your limits. Okay? So let's go. Evaluate the series to the given term, 2 plus 4 plus 6 plus 8, all the way to the 10th term. Seems like we're adding 2 each time, so this looks like an arithmetic series. So again, the formula is n over 2 times a1 plus an. Good news, I know there's 10 terms, so n is 10. The first term is 2, but regrettably, I don't know the last term, so we're going to have to find it, kind of like we did number 43. We have to use the sequence formula. Okay. It's d times n minus 1. I want the, 10th term, right? So I take the first term plus the common difference, which is 2, because we're adding 2 every time. So you do 2 plus 2 times 9. So that'll be 2 plus 18, which is 20. So 20 is the last term, okay? Anyway, you get 5 times 22, so it'll be 110. That's the sum, okay? In March, family starts saving for a vacation they're planning. The family starts with $125. That seems like A1. Each month they plan to deposit 25% more than the previous month. So this is kind of your R value, only you kind of have to add 1 to it because they're increasing every month. Okay, they're just not adding, they're adding 25% to what they had before, so 1.25. Okay, that's R. How much total money will they have after 6 months? That's N. Well, this is geometric because we have R, right? They're doing a percent as opposed to a flat rate. So the series formula for geometric is A1 times 1 minus R to the N all over 1 minus R. Okay, so you just have to plug things in. The sum of the first 6 months, you take the first term, which is 125, times 1 minus R, which is 1.25, to the 6th power, divided by 1 minus 1.25. Okay, so you kind of just have to plug this stuff in your calculator. So when I do 1 minus that inside, so I get 125 times like negative 2.814697. You can check that if you don't believe me. Over, this is obviously going to be negative 0.25. So basically just multiply that out. Take 125 times the answer in your calculator and divide by negative 0.25. You should get, we'll go ahead and write it down here, why not, $1,407.35 roughly. Okay. Just really it's a calculator problem. Okay. That's how much they'll have saved. Evaluate 8P3. This is really just a plug and chug exercise in your calculator. Okay. You should all have P on your calculator somewhere. You might have to type the 8, then hit NPR, and then type 3. You should get 336. You, of course, could use the formula if you wanted to, but you don't need to. Salad bar offers 8 choices of toppings for a salad. In how many ways can you choose 4 toppings? Well, let's think about a salad bar. Mr. Cruze walks up to a salad bar. There's 8 different toppings, but I can only pick 4. Does order really matter in what order I put the toppings on the salad? Does it matter if I put the bacon bits on first after the hard-boiled eggs? No. I can put them on in any order. So since order doesn't matter, this is going to be 8 combination 4. Okay. Remember permutations, like this one, order matters. Okay. So you might want to write this. Order matters. Combinations, order does not matter. All right. Really doesn't matter what order things come in. So 8 combination 4. Then you just type that in your calculator and you should get 70. So there's 70 different ways I can choose 4 toppings. Suppose I have 8 pencils in my book bag. 5 are yellow, 1's blue, and 2 are red. Today I grab 1 without looking and I return it. That's important. And tomorrow I do the exact same thing. What's the probability that I grab a pencil, a yellow pencil, and a yellow pencil? So basically yellow and yellow is what I want to know. Well, since I am replacing it, that makes life a little easier. First, what's the probability of getting a yellow on the first day? Well, 5 out of 8 of them are yellow, so it's 5/8. How about the second day? Well, since I replaced it, it's still going to be the same probability, 5 out of 8. And since it's and, I'm just going to multiply. So this will be 25 over 64. which is what as a percent? Let's see. It's roughly 39.1%-ish, approximately. So not bad odds if I get a yellow into yellow. Okay. Probability of recipient's male given the degrees, associate's degrees. So this is a table. We've seen this table a lot, right? When I have these conditional probabilities, something's happening given something else, the first thing you look for is both of these. Male associate's degrees. So how many male associate's degrees do we have? 245. Okay. Out of, well, the given really tells us our total. Given that the degree is an associate's degree. So I am looking only out of the people who have associate's degrees, how many of them are male, basically. Okay? So I have to take 245 plus 433, which is 678. So you do 245 divided by 678. And you get 36.1% approximately. Okay? So again, you take the combination of the two, male and associates, divided by the total number of what's given. Given always goes on the bottom. Okay? 50. Find the range, interquartile range of 56, 65, 73, 59, 78, 65, 59, 66. Well, let's put this in order. Let's see. 56 looks like the smallest, followed by two 59s, right? Followed by two 65s, 66, and a 73. And a 78. Let me check. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. 8 and 8, so we're good. The range is just high minus low. High minus low. So 78 minus 56. So you get 22. That's your range. Okay, your range is 22. 78 minus 56. Inner quartile range, we actually have to find the quartiles, right? The first quartile you have to find is the median, which is the very middle number. And you can see it's actually going to be between 65 and 65 because we have an even number of data. Well, what's between 65 and 65? That's 65. That's Q2. Now notice that Q2 is not, even though it's 65, it's technically not a part of the data. So, I think I did this last time and this worked really well. Let's look at the bottom half, or let's look at the bottom half of the data. What's the median of the bottom half? Well, it's going to be between 59 and 59. So it's 59. That's Q1. Okay? Let me make that 9 look a little better. It's Q1. Let's do the same now. Oop, I erased the wrong thing. Let's do the same now for... Of course, I erased a bunch of stuff. What were those numbers again? Let's see, it was what, 65? That was a 7, okay. Let's do the same thing for the bottom half now. What's the median between 66 and 73? Well, I'm going to have to average them, right? 73 plus 66 divided by 2 should be 69.5. That's Q3. Well, anyway. I don't know why it deleted it like that. Anyway, your interquartile range is Q3 minus Q1. So you do 69.5 minus 59, and you get 10.5 for your interquartile range. Okay, that's your IQR. All right, make a box and whisker plot for the set of data 12, 11, 15, 12, 19, 20, 19, 14, 18, 15, 16. So through the miracle of modern technology, I've already put them in an order for you, okay? Box and whisker plot, you need 5 numbers. Okay, you need the low, you need Q1, you need Q2, you need Q3, and you need the high. We've got the low and the high, that's pretty easy. We just need to find the quartiles. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. This one's right in the middle, because there are 5 below it and 5 above it. That's Q2, okay? Now let's look at the bottom half of the data. 1, 2, 3, 4, 5. Right in the middle is 12. That's Q1. 1, 2, 3, 4, 5. 19 is right in the middle there. It's Q3. Now you just make a little box and whisker. So let's see. We'll just go by 1, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's okay. That's good enough. Okay. We'll use black here. So low point is at 11, you put a dot. High point is 20, you put a dot. Okay, the dots are always the high and the low. Then you put little bars for Q1, which is 12, Q2, which is 15, and 19, which is Q3. And you connect those bars into a box, and then you have your little whiskers. You connect the dots to the box, and boom, box and whisker plot. Okay? Let's see, we got a little time left. So, find the mean, variance, and standard deviation of the data set. Okay. Standard deviation. I like to make a little table. Okay. Let's see, you do X. So let's first get our data on here. 13, 15, 17, 18, 12, 21, and 10. Okay. Then you need to find X bar. Well, X bar is the mean. So I'm going to find the mean of all those data points. And when I add them up and divide by 7, I get 15 point, well, let's go with 15.1. 15.1 is probably good enough. I mean, it's your choice how many places you want to use, but it's going to be the same for every number. Then you subtract those two numbers, x minus x bar, okay? So you do 13 minus 15.1, and you get negative 2.1. 15 minus 15.1 is negative 0.1. 17 minus 15.1 is 1.9. 18 minus 15.1 is 2.9. Let's see, 12 minus 15.1 is negative 3.1. 21 minus 15.1 would be 5.9. Yeah, that's right. And then 10 minus 15.1 is, let's see, negative 5.1. Right? Then I square all those. I take x minus x bar squared. So I have to square negative 2.1. Really, the negative doesn't quite matter at this point because when I square them, they should end up being positive. 0.01, let's see, 1.9 squared ends up being 3.61. 2.9 squared will be 8.41. 3.1 squared will be 9.61. 5.9 squared will be 34.81. And 5.1 squared will be 26.01. Okay. You see this last column? We're going to find the average because variance is basically the average. You take the sum of all the x minus x bar squareds and you divide by the total number of numbers. It's an average. We're going to average this last column. Okay? So first, let's add them all up, and then we'll divide by n. N is 7 because there's 7 numbers. Okay? When I do it, I get 86.87. That's the total of adding them all up. You divide that by 7, and you get 12.41 for the variance. Now, the question is, how do I get standard deviation? Well, standard deviation is just the square root of the variance. So you square root 12.41, and you get roughly 3.5. So there's your standard deviation. There's your variance. Oh, by the way, they did ask for the mean, so that's 15.1. You can put that over here. And that's it. So is it a little bit of a complicated process? Yeah, a little bit. But really, the math behind it isn't very complex, okay? I think we'll pause it here. And we'll finish these off in the next video, all right? As always, tweet me, email me, whatever. Whatever it takes to get a hold of me. I want you to do well on this final, all right? This is hugely, hugely important. 20% of your semester grade, all right? Good luck.